For Wednesday's video, we're going to talk about holes. A hole in a graph is called a discontinuity. It's where the graph continues through, but it does not exist at that point. And so it really is like a hole in the graph. Like you could have a whole line with a little hole in the middle of it. Now you get a hole, if you look at the same definitions from back on Monday, right here, we talked about it one time on Monday also. If you have a factor that's both in the numerator and in the denominator, then you get a hole in the equation. Now tomorrow when we graph everything, it'll be a little more evident. But for today, we want to actually calculate where those holes are located. I need you to get your graphing calculators out and pause the video if you need first before we keep going. You might want to also get out your factoring review from last week because we're going to be factoring polynomials and finding these holes. On the first example, when I factor both the numerator and denominator, my numerator I can use the MA method and I get x minus 2 times x plus 1. In the denominator, it doesn't factor, so I just throw it in some parentheses. You can see that, like we talked about Monday, you have an x minus 2 and an x minus 2 both in the numerator and denominator. Those actually cross out, and they're gone. That leaves us with a hole where x is equal to 2. But it's a hole at a coordinate 2 something. I find that coordinate by simplifying this equation, and it just becomes x plus 1, no fraction anymore. And if you plug 2, we got 2 for my hole for x. If you plug 2 in here, we get y is 3. That means that the hole is at 2, 3, the coordinates of the hole. Or you might see that it's just written the hole at x equals 2. In the second problem, we need to factor the denominator and then find the hole. My factoring, again, is the MA method. In the numerator, it doesn't factor. I just have x minus 3. In the denominator, I factor, and I get x minus 3, times x minus 1. And you can see that we have an x minus 3 in both the numerator and the denominator, so those are going to cancel. But that time it leaves me a 1 in the numerator. My equation simplifies into 1 over x minus 1. That's where you're going to need to calculate that hole. This time my hole is at x equals 3, and it's a coordinate of 3 what? If I plug a 3 in for x, I get 1 over 3 minus 1. 3 minus 1 is 2. That is 1/2. I would have a hole at 3, 1/2. So the coordinates of the hole when I plot it are 3, 1/2. But you might see it written that you just have a hole at x equals 3. You have to know where to plot it, though, when we complete our graphs for tomorrow. Now the last one, again, we have some MA method to do. The numerator stays the same, x plus 1, put it in parentheses. The denominator is x plus 2 times x minus 1. Do you see a factor? Any factors that are both in the numerator and denominator? They're close, but there aren't a matching factor to the x plus 1 down here. There isn't. So therefore, there is no hole. There's no hole in this one. And we'll talk about that more with the graphing tomorrow. Your assignment is to do these bottom problems. Just give me the holes. Now it says the coordinates of the holes. That means you need to give me the x and the y. You're going to find the x and then plug it in to get the y. Okay, I'll talk to you again tomorrow.